Alright, so we're going to talk about continuity today. So the informal, there's an informal definition slash the notion of what it means to be continuous. So a function, say f of x, is continuous on some region if its graph is connected. Okay, so you've probably heard of this. A function is continuous if you can draw its graph without lifting your pencil or your pen. And so that is the definition of what it means to be continuous. So just some terminology, if a function is not continuous, the term for that is what we call discontinuous. Okay, so there are three types. There are exactly three types of discontinuities. In other words, there are exactly three ways that a function cannot be continuous. So what are the three ways? So you can have a hole, you can have a vertical asymptote, so that's like an infinite spike. This is an infinite spike. Oops. Infinite spike. Or you can have a jump. Okay, so we care about continuous functions, and so to get familiar with them, it's good to analyze the things that we want to avoid. We want to avoid discontinuities, and there are three different types: jumps, holes, and asymptotes. So let's illustrate these three different situations that we want to avoid. So the first example is if we have the function f of x is x squared minus 1 over x, well, it doesn't matter, I'll say x minus 1. So this has a hole at x is equal to 1. Okay? And one way that we can see that is that f of x, just using some algebra, we can factor the numerator, difference of squares, or you can use the AC method. And this is what we get. And now if we notice, there's this common factor here. Now the problem is that if x is equal to 1, then we get 0 over 0, which is undefined. So this is undefined at x is equal to 1. Just look at the function. If you plug in x equals 1, you get 0 over 0, which is undefined. But if x is not equal to 1, then we can cancel out the yellow piece. And when we cancel out, this is what we get. We get x plus 1 for all other x. For all x. Except for 1. And so the function f of x really looks just like the line y equals x plus 1, except it's undefined when x is equal to 1. So if we were to look at a graph of this function, the graph of the function, let's plot a couple of points, 1, 2, 3, 1, 2, 3, 4, 1, 2. So if we were to graph this thing, then we see when x is equal to 0, y is equal to 1. You just do the calculation yourself. When x is equal to 1, it's undefined. When x is equal to 2, it gives you a 3. When x is equal to 3, it gives you a 4. When x is equal to negative 1, it gives you a 0, and so on and so forth. But it's undefined here. But you would find that there's actually just a hole. As long as you avoid x when x is equal to 1, and then everything else falls along the line. So you have, right here, you have a hole, and the hole is located at x equals 1. And the corresponding y value would be y is equal to 2. So that's where the hole is actually located. And so this function is not continuous at x equals 1. So it's continuous except at x is equal to 1. So it's discontinuous at x equals 1. So that's how we would say this. And that's the only place it's discontinuous. So it's continuous at all other x. Okay? So as long as you avoid, so what that means is if you can pick any other region. So if you look at like this region over here, then you're looking at this part of the graph, and that part of the graph is connected. Okay? Or if you look at like this region over here, then the line continues, of course. So it's continuous. If you look at any portion of the graph that avoids that hole, then it's continuous. So it is discontinuous at exactly one place, and that place is x equals 1. So that's how you can have a hole. Okay, so there's a hole. That's what a hole means. It means literally there's a hole in the graph. Okay, here's another example of what can go wrong. Say f of x is 1 over the absolute value of x. Okay, so note that f of 0 is undefined. But note also that the limit as x approaches 0 of f of x, well, it's going to infinity. And so one way we can see that is just by looking at the graph. So if we look at the graph of this function, so 1 is positive, the absolute value of x is positive, so it only spits out positive numbers. So if you plug in like 1, gives you 1, 1 over 1 is 1, if you plug in negative 1, if you plug in like 10, you're doing 1 divided by 10, so it's getting smaller and smaller and smaller. But as you get closer to 0, think of if x is really small, like 1 over 100, 1 divided by 1 over 100 is 100, so it's jumping up like this. And so the graph looks like this thing here. So as your x values are getting closer to 0, you see that the height just keeps getting larger and larger and larger and larger and larger and larger and larger. But anyways, there's no peak to this. It just keeps getting larger and larger and larger and larger and larger. And so you can see that there's a discontinuity here. You cannot connect the graph that's to the left of x equals 0. So here's x equals 0. Here's our x-axis. Here's our y-axis. The graph is just disconnected. There's the left part and there's the right part, and there's no way to combine them because they don't ever, each of these just gets larger and larger and larger. There's no end point. There's no height. The height keeps growing out to infinity. So this is what we mean by an asymptote. This is a vertical asymptote. So it's like a vertical spike. It just means that the height of the function, if you look at the graph, just gets arbitrarily large. So infinity is not a number, but if it were a number, it's like the height is infinity. The height it keeps getting bigger and bigger and bigger, and there's no actual infinity, so we can't graph that point. It doesn't actually connect. So the left part of the graph and the right part of the graph are never connected. It's disconnected, so it's not continuous. And then the last type of situation that occur is, let me just finish this. So this is, so 1 over x, that's absolute value, is discontinuous at x equals 0. But everywhere else it's continuous. So if you pick a region to the left, it's continuous. If you pick a region to the right, it's continuous. The bad point just occurs. There's only one bad point. It's when x is equal to 0. Okay, and then the third type of situation we can occur is if you have a jump. And anytime you're going to have a jump, a function will be given to you in pieces. So here's an example. There'll be some conditions. So here's just a simple example. Say it's x plus 1 if x is less than or equal to 2, and say it's x minus 1 if x is bigger than 2. Okay, so this is a piecewise defined function. There are sort of two different formulas that you have to use depending on where you're located. So if you look at the graph of this function, then something interesting happens at 2. If you're to the left of 2, so here's our x and here's 2, if you're to the left of 2, then you're using x plus 1. So when you're to the left of 2, if x is less than or equal to 2, then you're looking at the graph of y equals x plus 1. So if you're looking at the graph of that, 1, 2, 3, then it looks like this. This, it goes through some points. This is the point 2, 3. This is the point 0, 1. This is the point minus 1, 0. And it's just a regular, but the line now is only going to the right. Sorry, the line goes forever to the left, but it stops once you get to x equals 2. Okay, so that's what the function does. If x is less than or equal to 2, then you fall along that line, y equals x plus 1. Now, for x bigger than 2, then you fall along the line y equals x minus 1. So x minus 1, it still has a slope of 1, but now it's been shifted down by 2 units compared to the previous one. So it looks like this now. And again, the line continues forever. And so you can see quite clearly that we have a jump here. So there's a jump at x equals 2. And so again, this function is discontinuous. Discontinuous. Continue us at x equals 2. Okay, and so these are the three different situations that occur that will prevent you from being continuous. You either have a jump, or you have a vertical asymptote, or you have a hole. If you don't have these situations, then everything is continuous.